732 bytes. That's the size of the Python script that gives any unprivileged user root access on essentially every major Linux distribution shipped since 2017. It was disclosed yesterday. It's called copy fail. And the most unsettling part isn't the bug, and it's how it was found. The official designation is CVE 2026-31431. The researchers who found it called it copy fail. It's a logic bug in the Linux kernel's cryptographic subsystem, specifically in something called authencesn, a wrapper used internally by IPsec. When chained with a feature called AFALG and a specific in-place optimization added in 2017, the bug lets an unprivileged local user write 4 bytes, exactly 4, into the kernel's page cache for any file they can read. 4 bytes doesn't sound like much until you realize 4 bytes is enough to flip a check inside a Cetowid binary, and that's all it takes. So why does this matter beyond yet another CVE and a sea of them? 3 reasons. First, scope. The same exact 732 byte script roots Ubuntu, RHEL, Amazon Linux, SUSE, verified across architectures. Same bytes, same outcome. There is essentially no major server Linux that isn't affected. Second, silence. Because the exploit modifies the kernel's in-memory page cache, not the file on disk. Traditional file integrity monitoring tools, anything that compares hashes will see absolutely nothing. The on-disk file is untouched. The running file is rooted. Third, simplicity. There's no race condition, no timing window, no retries. It's a straight line logic flaw. Run the script, your root. Here's the part every security engineer should sit with. This bug was created by 3 innocent commits made by 3 different developers across 6 years. In 2011, somebody added authencesn for IPsec, looked fine. In 2015, somebody added AFALG socket support, so user space could talk to the kernel crypto API, also looked fine. And in 2017, somebody added a small in-place optimization to algfaad.c, also looked fine. Each commit in isolation was reasonable, the combination exploitable, and the combination sat in production kernels, completely undetected, for 9 years. Now here's the part that should genuinely change how you think about this industry. Copy fail wasn't found by a person reading kernel source for years. It was surfaced by an automated system from a company called Xint Code in roughly an hour of scan time against the Linux crypto subsystem with 1 operator prompt and no custom harnessing. 1 operator prompt. For 3 decades, the implicit deal in open source security has been this. Given enough eyeballs, all bugs are shallow. That assumption is now under stress. The eyeballs got tired, the combinatorics got too big, and the AIs do not get tired. This is one of the first headline-grade Linux kernel vulnerabilities found primarily by an AI. It will not be the last. So what do you actually do? Patches are out. Ubuntu, RHEL, Amazon Linux, SUSE, all shipped fixes. Step 1, update your kernel. Today, not Friday, not after the freeze. Step 2, if you can't immediately patch, the recommended mitigation is to disable the algfaad kernel module persistently on every affected system. That blocks the AFALG path the exploit needs. Step 3, and this one is bigger than this CVE, stop relying on file hash integrity monitoring as your primary detection layer for kernel-level compromise. CopyFail demonstrated that the page cache-only modification class of attack is real, in production, and patient. Local privilege escalation, that's the limitation. You need code execution as a regular user before CopyFail buys your root. So who should be most concerned? Multi-tenant systems, shared hosting, CI runners, development boxes where contractors and engineers have shells, container hosts where a container escape becomes a full system compromise, bastion hosts, any environment where user and root are supposed to be a meaningful boundary. If your threat model says you trust everyone with a shell, you're probably fine. If it doesn't, you have a 732 byte problem. Step back from the CVE for a second. CopyFail tells us 3 things. The Linux kernel is enormous, evolving, and provably contains bugs nobody has the time to surface manually. We have been operating under a security assumption that has just visibly cracked. Cryptographic plumbing, the boring stuff, the wrappers, the optimization paths, is not boring. It is one of the most concentrated security critical surfaces in modern computing, and it is hard to review. And AI systems can now find serious kernel bugs faster than humans. That is not hypothetical. That is a Tuesday in April. If you're a defender, this means your patch cycle has to compress. If you're an attacker, well, your tooling already updated. So here's the takeaway. CopyFail is not the worst Linux kernel bug ever disclosed. It needs local code execution. The patch is shipped. The mitigation is 1 kernel module away. But it is the first really loud signal that the next decade of vulnerability research is going to look very different from the last one. AIs are going to surface logic bugs that hid in plain sight for years. And every defender on the planet now has to assume that the same techniques are being run right now by people who do not write blog posts. Update your kernels, disable algif AA8 if you can't, and start asking your security team a different question. Not what bugs do we know about, but what could a focused AI find in our stack in an hour? One more thing. This is the kind of attack that breaks the security tools you bought 5 years ago. Hash-based file integrity monitoring sees nothing. The file on disk is unchanged. Vulnerability scanners flag the kernel, but only after the patch ships and only if you're scanning. The window between disclosure and patch is exactly when attackers move. The category of tool that does see this is Linux runtime detection. Sandfly Security is a Gula Tech Adventures portfolio company built for exactly that job. Their entire focus is Linux systems, agentless, like looking for the things that come after a privilege escalation. An unprivileged user suddenly running as root, a set-to-it binary doing something it has never done before, a new SSH key planted in a place no legitimate process would put it, a backdoor binary in a directory no package owns. Copy fail itself runs in 732 bytes. The backdoor that gets installed afterwards is what kills you a month later. Sandfly is built to catch that part. Patch your kernels and know who's watching after the patch is too late. That's the show. Thanks for watching. Thanks for liking. And please patch your systems.